Hello, and thank you for joining me on this journey. Tonight, we will slowly drift into the luminous story of gold's cosmic origins, where ancient stars crafted tiny particles that would one day shimmer in our hands. Imagine the vastness of space, dotted with glowing stars, each one a furnace of creation. Within these stellar hearts, gold was born in flashes of light and heat, journeying across galaxies before finding its place on our planet. Let your mind wander through the glittering expanse, feeling the slow pulse of the universe, and sense how every atom of gold carries this cosmic story. If you enjoy these relaxing moments, please consider leaving a like, subscribing, and turning on all notifications so you don't miss any of our future videos. But for now, just breathe. Let your body relax, release any tension, and allow your mind to drift. Let's begin. Beneath the seafloor, dissolved traces of this metal circulate through hydrothermal vents, where superheated water interacts with basalt and leaches minute quantities from oceanic crust. When that mineral-rich fluid meets colder seawater, metallic particles precipitate and settle, contributing to marine sediments. Although concentrations are far lower than in continental mines, these submarine systems reveal that Earth continues concentrating the element in hidden, largely inaccessible environments. During the Klondike Rush of the 1890s in Canada's Yukon Territory, stampeders endured treacherous routes such as the Chilkoot Trail, hauling a year's worth of supplies to comply with border regulations. The extreme cold, avalanches, and isolation claimed many lives before prospectors even reached the creeks. Yet the promise of striking pay dirt transformed remote northern valleys into bustling settlements almost overnight. Measured by density, this element weighs about 19.3 grams per cubic centimeter, making it far heavier than common rock-forming minerals. That heft explains why flakes sink rapidly in water and collect behind natural riffles in streams. Prospectors learned to read river currents, recognizing that the densest material would lodge in crevices along bedrock rather than remain suspended in flowing sediment. Alchemy once regarded the metal as the perfect substance, symbolized by the sun and believed to represent incorruptibility. Medieval practitioners sought the philosopher's stone in hopes of transmuting base metals into radiant treasure. Although transmutation proved impossible through chemistry, modern nuclear physics has demonstrated that altering atomic nuclei could, in theory, convert other elements into this one, albeit at immense cost. At Fort Knox in Kentucky, a heavily guarded depository stores thousands of metric tons of bullion belonging to the United States Treasury. Constructed in 1936, the granite building became synonymous with security, reinforced by steel, concrete, and constant surveillance. While it holds only part of national reserves, its reputation has embedded the site deeply in popular imagination. Across medieval Europe, artisans applied thin leaf to illuminate manuscripts, laying shimmering backgrounds behind sacred figures. When candlelight flickered across these pages, reflective surfaces created a luminous effect that suggested divine radiance. The technique required painstaking skill, as sheets thinner than tissue had to be positioned precisely onto prepared parchment coated with adhesive gesso. In modern laboratories, nanoparticles composed of this element exhibit unusual optical behavior known as surface plasmon resonance. When struck by specific wavelengths of light, electrons oscillate collectively, producing vivid reds and purples in colloidal solutions. Researchers exploit this property in medical diagnostics, where color changes can signal the presence of particular biomolecules in rapid testing kits. Deep within the Earth's mantle, immense pressure and heat keep most of the planet's supply locked far beyond human reach. Geochemical studies suggest that if all mantle reserves were brought to the surface, they could coat the entire planet in a layer several meters thick. The scarcity experienced by civilizations reflects accessibility rather than absolute abundance. During the reign of King Croesus of Lydia in the 6th century BCE, standardized coins made from refined metal revolutionized trade in Anatolia. By stamping official emblems onto measured pieces, authorities guaranteed weight and purity, simplifying commerce across regions. This innovation spread through the Mediterranean world, anchoring monetary systems in tangible, widely trusted material. In dentistry's early modern era, practitioners prized the metal for fillings because it could be compacted directly into cavities without cracking teeth. Its compatibility with biological tissue minimized adverse reactions, a significant advantage before synthetic materials existed. Even today, certain restorations rely on high nobility alloys for durability in areas subject to intense chewing forces. Mercury amalgamation, once common in artisanal mining, involves mixing liquid mercury with crushed ore so that precious particles bind to it. Heating the amalgam vaporizes mercury, leaving behind concentrated metal but releasing toxic fumes. This practice has contaminated rivers and harmed miners in parts of South America, Africa, and Asia, prompting international efforts to curb mercury use. From a chemical standpoint, the element resists most acids, yet it dissolves in aqua regia, a mixture of nitric and hydrochloric acids. This potent solution forms chloroauric acid, enabling refinement and laboratory analysis. The paradox of a substance so inert succumbing to a specific blend fascinated early chemists and underscored the subtleties of reactivity. In architecture, domes clad with gilded panels catch sunlight from great distances, signaling cultural or religious importance. Moscow's Orthodox cathedrals and Myanmar's Shwedagon Pagoda exemplify how reflective surfaces amplify spiritual symbolism. Such structures require periodic maintenance, as thin exterior layers can erode under weathering, despite the underlying metal's resistance to corrosion. Electronic waste contains higher concentrations of this precious element per ton than many natural ores. Circuit boards, connectors, and memory chips incorporate microscopic coatings to ensure reliable conductivity. Specialized recycling facilities shred and smelt these components, extracting valuable material while reducing the environmental footprint associated with new mining ventures. In Olympic tradition, first-place medals are commonly described as gold, yet modern versions consist primarily of silver with a surface plating of the precious metal. The International Olympic Committee specifies minimum plating requirements, balancing symbolism with cost. Despite modest content, the cultural weight of the medal far exceeds its intrinsic material value. Therapeutically, certain gold-based compounds have been prescribed to treat rheumatoid arthritis, exploiting anti-inflammatory properties discovered in the 20th century. Although newer biologic drugs have reduced their use, these medications marked an important chapter in autoimmune treatment. Patients receiving such therapy required careful monitoring because accumulation in tissues could cause side effects. Bank vaults in London form one of the largest trading hubs for bullion worldwide, with bars stored beneath the city's financial district. the London Bullion Market Association sets standards for bar weight and purity, facilitating international transactions. Ownership often changes through electronic records without the bars physically moving, illustrating the abstraction of modern commodity markets. In jewelry traditions of West Africa, particularly among the Akan people of present-day Ghana, intricately cast weights once measured gold dust used as currency. These brass weights, shaped like animals or symbols, served both practical and artistic roles. Their designs encoded proverbs and social values, intertwining commerce with cultural expression. Astrophysicists confirmed in 2017 that a collision between two neutron stars observed as gravitational wave event produced heavy elements, including significant quantities of this metal. Spectroscopic data from the resulting kilonova matched predictions for rapid neutron capture nucleosynthesis. Such findings strengthened the understanding that cosmic cataclysms seeded galaxies with precious matter. On the atomic scale, relativistic effects influence the color of this element, as electrons moving at significant fractions of light speed alter energy levels and absorb blue light. The reflected spectrum shifts toward yellow, giving the metal its distinctive hue. Without these quantum mechanical nuances, it would appear silvery like many of its periodic neighbors. Volcanic eruptions sometimes carry tiny specks of this precious element in tephra, scattering them across landscapes. Though concentrations are minuscule, repeated deposition over thousands of years can enrich soils enough for later discovery. Ancient riverbeds often contain fragments washed from these volcanic sources, revealing how fiery geologic activity indirectly contributes to mineral wealth long after lava cools. Alchemists in medieval Europe often linked the metal with eternal life, embedding it in medicinal tinctures despite the lack of biological efficacy. Texts from the 15th century described powdered leaves dissolved in elixirs, believed to strengthen the body and preserve youth. Though modern medicine discredits these claims, the pursuit reflects enduring human fascination with incorruptible matter and its imagined transformative powers. The Serra Pelada mine in Brazil became infamous in the 1980s as thousands of workers carved into an enormous open pit by hand, forming a sea of human labor against bright reddish earth. Pictures from above reveal human figures appearing almost miniature against vast piles of rock, capturing both desperation and the scale of the scramble for fortune. When scientists coat materials with nanoparticles of this metal, unusual chemical and optical properties emerge, enabling the detection of single molecules. In biomedical imaging, cells tagged with these particles scatter light, enhancing contrast under microscopes. These tiny spheres act as bridges between physics and life sciences, turning an ancient material into a tool for microscopic exploration. A single cubic meter of seawater contains only a few grams of dissolved metal. Yet across the global oceans, the quantity is immense. Attempts to extract it economically remain experimental because processing such dilute solutions requires energy and technology exceeding the value of recovered material. Nevertheless, researchers continue to investigate desalination byproducts and novel sorbents as potential sources. Many traditional societies regarded the lustrous element as a bridge between the human and divine, using it to embellish idols, ceremonial masks, and crowns. Its reflective quality symbolized light and immortality, while its permanence suggested a form of spiritual endurance. Archaeological digs often reveal remnants of elaborate ritual artifacts whose brilliance has survived thousands of years. In the electronics industry, microchips are often soldered with alloys containing minute traces of the element to ensure stable electrical contact. Even microscopic failures can cascade through circuits, so reliability demands meticulous coating. Tiny connectors in aerospace systems or medical implants sometimes carry only milligrams, yet these small amounts are indispensable for flawless operation. Deposits in Alaska's Nome region were largely placer formations, where repeated glacial movements exposed concentrations in river gravels. Prospectors endured harsh winters and unpredictable floods, learning to interpret subtle shifts in sand and gravel to locate pockets of heavy metal. The interplay of ice, rock, and water-sculpted landscapes that dictated the success or failure of mining expeditions. During the California gold rush, the sudden influx of miners created makeshift towns with haphazard sanitation, marketplaces, and gambling halls. The transient settlements altered river courses and cut roads through forests, leaving long-term ecological scars. Newspapers and personal journals from the era capture both the dazzling promise of wealth and the harsh realities of frontier life. Atomic-scale studies reveal that electrons in the element's outer shells experience relativistic contraction, which influences bonding and color. These quantum phenomena make it chemically unique among transition metals and account for its distinct hue compared to silver or copper. Understanding these effects has enabled chemists to predict reactivity, alloy behavior, and optical characteristics with unprecedented precision. In Islamic architecture, minarets and domes often carry thin leaf applications to signal status and piety, reflecting sunlight across courtyards. Maintenance crews carefully restore these surfaces, preserving both the symbolic significance and the visual impact. Over centuries, oxidation-resistant properties allow a thin layer to endure climatic extremes, while maintaining a radiant presence visible from a distance. Some of the world's heaviest nuggets have been transported to museums, weighing tens of kilograms, serving as a testament to nature's occasional generosity. These specimens inspire curiosity and admiration, illustrating that metallic concentrations can form enormous aggregates, not just microscopic specks. Viewers often marvel at how dense, soft, and lustrous a single chunk can appear. In high-precision nanotechnology, this element can form monolayers on silicon or glass, providing conductive pathways for sensors. Or biochemical assays. A layer only a few atoms thick can dramatically alter surface chemistry, enabling selective attachment of molecules or controlling light reflection. These applications extend from lab research to industrial production of highly sensitive diagnostic devices. Hydraulic mining during the 19th century created dramatic sediment flows, washing away hillsides and leaving unnaturally red cliffs. While efficient, this technique generated long-term environmental impacts, including silted rivers and destroyed forests. Historic photographs capture the chaotic, yet mesmerizing human orchestration of water and earth to reveal hidden veins of precious metal. The Shinkolobwe mine in Democratic Republic of the Congo is known for producing some of the purest uranium-bearing ores, but historical records also indicate notable concentrations of the lustrous element. This duality highlights how complex geochemistry can localize multiple rare metals in overlapping deposits, influencing both mining strategy and geopolitical significance. Electroplating allows for thin, uniform coatings of metal on base materials, transforming everyday objects into corrosion-resistant, conductive or decorative surfaces. From luxury watches to aerospace connectors, the layer enhances durability while preserving the mechanical properties of the underlying material. Precision control ensures thickness, uniformity, which is critical for optical and electrical performance. Ancient Roman coins sometimes displayed alloys that included small proportions of the metal, providing both aesthetic appeal and measurable intrinsic value. Metallurgical analysis of these artifacts reveals changing techniques and intentional debasement, offering historians clues about economic conditions and state policies during different emperors' reigns. The element exhibits an exceptional ability to form stable complexes with sulfur-containing compounds, which influences its corrosion resistance in jewelry and industrial applications. This affinity also enables selective chemical reactions in laboratories, allowing researchers to manipulate molecular assemblies on surfaces and create advanced catalysts for chemical synthesis. Several cultures in pre-Columbian Central America used the element as a medium for storytelling, casting miniature figures, animals, and symbolic objects to accompany ritual events. Such figurines often demonstrate exquisite craftsmanship and social meaning, revealing that the value of the material extended beyond wealth to narrative, spiritual, and status functions. Mining in regions like the Carlin Trend in United States relies on low-grade deposits invisible to the naked eye. Miners use large-scale open pits and chemical extraction methods to recover trace amounts, highlighting that massive output can result even from ore with seemingly negligible concentrations. This scale of industrial operation reflects both technological advances and economic incentives. Molten flows of lava in volcanic regions occasionally encapsulate tiny droplets of this precious metal, which solidify as the rock cools. Over centuries, erosion releases these particles into rivers and valleys, concentrating them in gravels. Ancient miners often exploited these secondary deposits, exploiting nature's redistribution of metallic wealth in sediments shaped by water and gravity. The chemical inertness of this element makes it resistant to tarnish, yet it forms intriguing compounds with halogens, such as gold chloride, which chemists study for its vibrant colors and catalytic potential. Laboratory experiments have demonstrated that these compounds can mediate selective reactions, providing insights into chemical bonding and surface interactions that inform both materials, science, and nanotechnology. In Myanmar, artisans apply thin layers to temples and pagodas, creating shimmering surfaces that glint beneath tropical sun and monsoon clouds. Such adornments require ongoing maintenance, as the leafed surfaces can peel under extreme humidity. Yet even centuries-old applications maintain a radiant brilliance that conveys both spiritual and cultural continuity. Meteorite impacts sometimes concentrate trace amounts of this metal in ejecta layers, revealing that extraterrestrial events have contributed to its distribution on Earth. Geologists identify these anomalies through isotopic analysis, detecting atoms that bear signatures distinct from terrestrial sources. The findings underscore the cosmic origins of heavy elements and their complex journey to accessible deposits. The metal's exceptional ductility allows it to be drawn into wires thinner than human hair, which are critical in high-precision electrical applications. Microelectronics, spacecraft systems, and laboratory instruments rely on these filaments, where even minute interruptions can compromise performance. Manufacturing demands microscopic accuracy to maintain continuity and signal fidelity in delicate environments. Medieval European kings sometimes required tribute payments in the form of ingots or jewelry, reflecting both material wealth and political leverage. These contributions funded armies, palaces, and ceremonial life, while reinforcing the association of precious metals with sovereignty. Coins minted from these reserves also circulated widely, reinforcing the economic influence of ruling elites. The Witwatersrand region in South Africa contains reefs deeply embedded under kilometers of rock, demanding extensive underground infrastructure to access. Mining engineers construct ventilation shafts, pumping systems, and reinforced tunnels to reach veins under extreme pressure and heat. The scale and complexity of these operations underscore human ingenuity in extracting concentrated metals from deep geological formations. Ancient Chinese artisans refined metallurgical techniques to create delicate filigree, combining thin threads with casting methods. Such objects, often jewelry or ritual implements, demonstrated both aesthetic mastery and technical knowledge, illustrating that sophisticated craftsmanship has coexisted with utilitarian and symbolic uses for thousands of years. In modern medicine, colloidal suspensions of this element act as contrast agents in imaging studies, highlighting tumors and blood vessels under specific light conditions. The particles' interaction with electromagnetic waves improves visibility without significantly impacting surrounding tissue, demonstrating a convergence of chemistry, physics, and clinical application that leverages centuries-old material in a futuristic context. Alloying with platinum or palladium can produce white-hued versions suitable for jewelry, industrial contacts, and electronic components. These alloys retain the corrosion resistance and conductivity of the base element, while achieving mechanical strength suitable for repeated handling or structural use. Fine-tuning of proportions enables craftsmen to balance appearance, durability, and functionality for varied applications. During the Klondike Gold Rush, creeks and riverbeds became theaters of human ambition, with prospectors erecting sluices, riffles, and wooden flumes. The rapid extraction of sediment reshaped landscapes, redirected water, and displaced local flora and fauna. Journals and photographs from the period convey both hardship and exhilaration, revealing the physical and social dimensions of intensive manual mining. Nanoparticles exhibit plasmonic resonance, creating vibrant color shifts observable in laboratory experiments and industrial applications. These optical properties enable precise biosensing, chemical detection, and novel materials development. The ability to manipulate matter at this scale allows researchers to harness the metal's reflective and conductive behavior in ways unimaginable for traditional bulk applications. Hydraulic mining techniques in 19th century California relied on pressurized water to dislodge sediment, producing both economic gain and massive environmental disruption. Rivers were silted, forests cleared, and hillsides transformed. These historical scars provide a stark visual reminder of the tension between resource extraction and ecological preservation, echoing contemporary concerns in mining-intensive regions. Royal treasuries of medieval Europe often contained ingots, coins, and ceremonial objects, which symbolized both wealth and authority. Inventory lists reveal the meticulous tracking of these stores, highlighting that accumulation was both an economic and political instrument. Such reserves enabled rulers to finance warfare, diplomacy, and monumental architecture, intertwining financial control with societal influence. In electronic circuits, plating critical connectors with this metal prevents oxidation and maintains signal integrity over decades. Even tiny disruptions can cause failure in spacecraft, medical devices, or high-frequency communication systems. The element's combination of conductivity, corrosion resistance, and ductility makes it indispensable for modern technology, far beyond aesthetic or monetary value. Archaeologists have discovered ritual objects in pre-Columbian societies formed entirely from this metal, representing cosmological ideas and elite status. Cast figurines, jewelry, and ceremonial vessels often feature intricate designs, reflecting technical sophistication and cultural expression. Their preservation over centuries attests to the chemical stability and enduring allure of the material. Seismic activity can expose new veins as fault movement fractures host rock and allows hydrothermal fluids to deposit dissolved metals. Miners have historically traced these natural fractures to locate lodes, following patterns invisible on the surface, but hinted at by subtle geological indicators. Such dynamic geology ensures that deposits are not static, but evolve with tectonic forces. Urban recycling facilities now recover significant quantities from discarded electronics, achieving yields higher than many traditional mines. Circuit boards, connectors, and memory chips are shredded and chemically treated to extract trace metals. This secondary source reduces environmental disruption from mining while supplying material for jewelry, electronics, and industrial use, highlighting sustainable avenues for resource management. The auric content of coins minted in ancient Lydia and Persia demonstrates early mastery of alloying, enabling standardization and trusted value across regions. Metallurgical studies reveal precise control of purity and weight, illustrating sophisticated economic systems and governmental oversight long before modern banking structures emerged. Tectonic collisions concentrate this element in shear zones, where intense pressure and friction heat surrounding rock, mobilizing trace metals. Veins formed under these conditions can extend for kilometers, creating valuable lode deposits. Geologists study the orientation and mineral composition of these zones to predict locations of high-density accumulations for future exploration and extraction. In modern spacecraft, reflective coatings of this metal protect sensitive instruments from infrared radiation. Helmet visors and thermal blankets rely on ultra-thin layers to deflect heat while allowing visibility and sensor functionality. Engineers must carefully calibrate thickness and adhesion to balance weight, flexibility, and effectiveness, ensuring that explorers and instruments survive extreme conditions beyond Earth. Pre-Columbian cultures often smelted and cast tiny objects using intricate molds, producing animal figurines, amulets, and ritual implements. These artifacts demonstrate both metallurgical skill and symbolic communication, suggesting that artisans understood how to manipulate heat, alloy composition, and surface finishing. Archaeologists find that even small pieces convey extensive cultural and spiritual meaning, transcending their material value. Environmental studies show that abandoned mining areas contain tailings rich in sulfide minerals, which can generate acidic runoff when exposed to air and water. This acidity mobilizes heavy metals into streams, threatening ecosystems and human settlements. Contemporary remediation techniques involve stabilization, neutralization, and vegetation cover to prevent further degradation and restore landscape functionality. Scientific experiments with ultra-thin films reveal that a single layer of this element on glass or silicon can dramatically alter optical reflection. The films manipulate light at the nanoscale, enabling applications in solar panels, sensors, and advanced photonics. These studies illustrate how ancient material properties can inspire modern technology far beyond their traditional uses. In southern Africa, some of the earliest large-scale industrial mines reached depths exceeding 3 kilometers, exposing miners to extreme heat, rock pressure, and seismic events. Advanced cooling, ventilation, and safety systems were required to maintain operable conditions. The engineering ingenuity applied in these mines demonstrates human determination to extract metals from challenging geologic environments. Coins minted in the Roman Empire sometimes contained thin layers over base metal cores, balancing appearance, durability, and intrinsic value. Metallurgical analysis of these specimens reveals not only craftsmanship, but also economic policies designed to conserve precious metal while sustaining trade and commerce across vast territories. The reflective surface of this metal allows for its use in precision mirrors for telescopes and satellites. Thin coatings maintain optical integrity under variable thermal conditions, making instruments reliable for astrophysical observation. Even minor imperfections could distort signals, so deposition methods are carefully controlled to achieve uniformity at the microscopic level. Ancient Egyptians employed a technique known as depletion gilding, selectively removing copper from the surface of alloys to enrich the metal's appearance. This method produced a rich yellow sheen with minimal use of the precious material, demonstrating both resourcefulness and aesthetic sophistication. Surviving artifacts show remarkable preservation despite millennia of burial. Biological research has explored the use of nanoparticles to target tumors, exploiting their unique interaction with light and tissue. Metallic particles can carry drugs, enhance imaging contrast, or generate heat under specific wavelengths, enabling localized therapeutic effects. These applications transform an ancient element into a cutting-edge tool in modern medicine. Historic placer mines along Alaskan rivers illustrate how glacial retreat and sediment transport shaped concentrated deposits. Miners learned to read gravel bars, bedrock contours, and subtle color changes in sediments to identify rich pockets. The combination of observation, experience, and manual skill determined the success of individual prospectors in these remote, challenging environments. The unique electron configuration of this element contributes to its distinctive luster and color. Relativistic effects compress inner orbitals, influencing outer electrons' behavior and resulting in selective absorption of blue light. Without these effects, the metal would appear silvery, resembling other heavy transition metals. Quantum mechanics explains why its visual and chemical characteristics are so exceptional. Mining operations in the Carlin Trend of Nevada extract microscopic particles embedded in sedimentary rock, invisible to the naked eye. Chemical leaching and large-scale recovery techniques allow the accumulation of significant quantities over time. These deposits demonstrate how extensive industrial activity can exploit low-grade sources to meet global demand. In South American indigenous cultures, ceremonial masks and headdresses were often decorated with thin sheets, reflecting sunlight in ritual settings. The application of metallic leaf enhanced both visibility and perceived power, integrating art, religion, and material wealth. Surviving examples provide insight into pre-Columbian social hierarchies, aesthetic principles, and spiritual symbolism. Hydraulic mining during the 1800s produced dramatic sediment flows capable of transporting millions of tons of rock. Engineers built flumes, sluices, and diversion channels to concentrate heavy particles, leaving scars that remain visible today. These historical sites illustrate the environmental consequences of rapid extraction methods and the tension between human ambition and natural landscapes. The element's remarkable corrosion resistance makes it ideal for high-end watches, electronic connectors, and laboratory components. Even microscopic coatings prevent oxidation, maintaining both function and appearance over decades. Its combination of chemical stability, ductility, and conductivity ensures reliability under extreme or demanding conditions. In Islamic architecture, gilded domes and minarets reflect sunlight across courtyards and cityscapes, symbolizing divine light and authority. Maintenance requires careful restoration, as exposure to tropical climates can degrade delicate surfaces, yet enduring brilliance preserves centuries of cultural heritage. These visual markers underscore how material properties convey symbolism beyond monetary value. In laboratory settings, colloidal suspensions of nanoparticles create vivid red, purple, or blue hues, depending on particle size and aggregation. These optical effects are exploited in sensors, medical diagnostics, and experimental art installations. By controlling size and distribution, researchers manipulate light-matter interactions at scales invisible to the naked eye, producing striking visual and functional outcomes. Urban recycling programs recover significant quantities from obsolete electronics, effectively mining cities for valuable metals. Shredding, separation, and chemical extraction reclaim small amounts from circuit boards, connectors, and contacts, reducing pressure on natural deposits. This modern form of resource reclamation highlights sustainability, economic efficiency, and the continuity of material use across centuries. Meteorites occasionally deliver minute quantities, contributing to Earth's overall inventory of the element. Isotopic analysis confirms that some atoms originated from stellar explosions, linking terrestrial wealth to cosmic events. This celestial connection underscores that material we prize for beauty and utility has origins in violent, distant processes that shaped the universe long before human history began. During the 19th century Victorian gold rush, miners carved intricate flumes and channels into rugged hillsides to divert water, allowing sediment-rich streams to flow through sluices. The resulting concentrated deposits were collected and refined, while the exposed terrain displayed striking, unnatural scar patterns. These endeavors highlight human ingenuity and the dramatic environmental footprint of rapid mineral extraction. In modern electronics, connectors and circuit boards employ ultra-thin coatings to prevent corrosion and enhance conductivity. Even microscopic layers provide stability in high-frequency applications, such as satellites and advanced computing systems. The reliability of these devices depends on the unique combination of ductility, chemical resistance, and conductivity. demonstrating the indispensable role of this metal in contemporary technology. Royal treasuries throughout Europe amassed ingots, coins, and ornate objects, serving as symbols of both wealth and political authority. Detailed inventory records reveal meticulous oversight, illustrating how accumulation of this metal allowed rulers to finance armies, build monumental structures, and assert influence across territories. Such reserves reinforced economic stability and social hierarchy. In nanoscale research, particles of this element can act as catalysts, accelerating chemical reactions without being consumed. Their high surface area and chemical stability enable selective reactions that are critical in pharmaceuticals, environmental remediation, and materials science. Laboratory studies explore optimal particle size, shape, and surface functionalization to maximize efficiency and predictability. Placer mining along Alaska's creeks depended on understanding sediment layers, bedrock contours, and subtle coloration in gravel bars. Miners interpreted natural signals to locate rich concentrations, relying on observation, experience, and manual labor. The dynamic interaction of glacial retreat, river flow, and seasonal flooding continually reshaped deposits, creating both opportunity and challenge for prospectors. The distinctive yellow hue arises from relativistic effects on inner electrons, shifting absorption toward blue wavelengths. Without these quantum influences, the element would appear silvery, like neighboring transition metals. This subtle electronic behavior influences not only color, but also chemical bonding, corrosion resistance, and optical applications, revealing a deep connection between physics and observable properties. In South American indigenous societies, miniature ceremonial objects depicted animals, mythological figures, and deities, combining artistic skill with symbolic significance. Such artifacts served as both ritual implements and social markers, conveying stories, status, and religious meaning. Surviving examples demonstrate sophisticated craftsmanship and a cultural emphasis on visual storytelling mediated through precious metal objects. Industrial-scale mines in Nevada's Carlin Trend extract microscopic particles invisible to the naked eye. By employing leaching and other chemical methods, operators can recover significant quantities over time, demonstrating how modern engineering can exploit deposits that would have been inaccessible to early miners. The operation emphasizes scale, technology, and the economics of low-concentration sources. Cathedrals and temples often feature reflective leaf applications that catch sunlight, signaling spiritual significance and aesthetic mastery. Maintenance preserves brilliance against weathering, humidity, and wind, allowing religious and cultural messages to endure. These architectural features leverage the metal's optical properties to enhance both visual impact and symbolic resonance across generations. Hydraulic mining in historical California reshaped entire hillsides, creating enormous sediment flows. Engineers harnessed water pressure to concentrate heavy particles, while rivers, forests, and soil were dramatically altered. The physical transformation of the environment demonstrates the extraordinary human capacity to manipulate landscapes in pursuit of valuable resources, with consequences still visible in some areas today. Exceptional corrosion resistance allows fine coatings to protect electrical contacts in watches, laboratory instruments, and aerospace systems. Even microscopic layers prevent oxidation, ensuring decades of functional integrity. The combination of ductility, chemical inertness, and conductivity makes this material uniquely suited for demanding environments where failure is not an option, far beyond decorative or monetary use. Urban mining initiatives reclaim substantial quantities from discarded electronics, effectively transforming cities into sources of precious metals. Circuit boards, connectors, and memory chips are shredded and chemically treated to extract small but valuable amounts. This approach minimizes environmental disruption associated with traditional mining, while supplying material for technology, jewelry, and industrial applications. Tectonic compression creates shear zones where heat and friction mobilize trace metals, forming veins extending for kilometers. Geologists study mineral composition, orientation, and structural context to locate high-density accumulations for exploration. The dynamic interplay of pressure, temperature, and chemical mobility ensures that concentrated deposits form in geologically active regions, offering insight into both mineralogy and tectonics. Subsurface hydrothermal fluids circulating through fractured rock transport dissolved metallic elements, which precipitate when temperature and pressure conditions change. This mechanism forms many of the lode deposits historically mined in mountainous regions, where veins trace cracks and faults. Understanding these pathways is essential for geological prospecting and reveals the subtle forces shaping mineral distribution. Ancient coinage demonstrates alloying ingenuity, balancing appearance, durability, and intrinsic value. Analysis of Lydian, Persian, and Roman specimens reveals careful control of purity, weight, and aesthetics, providing insight into trade systems, governance, and economic strategies long before modern banking practices. Such artifacts preserve both technological and cultural knowledge. Volcanic tephra occasionally carries microscopic droplets that settle into surrounding soils, gradually enriching sediments over centuries. Weathering and erosion transport these particles into river gravels, where human prospectors later concentrated them through panning or sluicing. This natural redistribution links fiery geological activity with terrestrial accumulation, revealing a long chain of events from molten rock to discoverable metallic deposits. Meteoric dust contributes trace amounts, enriching Earth's crust with atoms forged in ancient supernovae. These cosmic deliveries supplement terrestrial sources and explain isotopic anomalies in some ore deposits. By analyzing ratios of heavy elements in sediments, scientists can distinguish material originating from space versus local geology, revealing a subtle but profound extraterrestrial contribution to Earth's metal wealth. In contemporary electronics, microscopic layers ensure conductivity in sensitive connections while resisting corrosion. Circuit boards, medical devices, and aerospace equipment rely on coatings just a few micrometers thick, which maintain integrity over decades. Even a single defect can disrupt performance, highlighting how minuscule amounts have disproportionate technological importance. Placer deposits along glacial river valleys often reveal accumulations hidden beneath sediment layers. Prospectors study water flow patterns, bedrock contours, and particle distribution to locate dense accumulations, sometimes only a few centimeters thick, but spread over large areas. The interplay of glaciers, rivers, and sedimentation determines how these deposits concentrate over millennia. Medieval Islamic architecture frequently employed thin layers on domes and minarets, producing reflective surfaces that captured sunlight and highlighted spiritual and political authority. Restoration requires careful craftsmanship to preserve both aesthetics and symbolism. These surfaces endure weather extremes while conveying cultural messages that connect viewers with centuries of artistry and ritual. Industrial-scale mining in regions like South Africa reaches extreme depths, exposing workers to heat, pressure, and seismic risks. Advanced ventilation, cooling, and structural engineering maintain safety in these subterranean networks. The scale of operation illustrates both the difficulty of accessing deep loads and the lengths humans will go to exploit concentrated deposits. Colloidal suspensions are employed in medical imaging and diagnostics, where nanoparticles interact with light to reveal cellular structures or detect molecular targets. Adjusting particle size alters scattering properties, creating vivid color changes used to monitor reactions in real time. Such innovations show how ancient materials find new roles in precision science. Ancient Roman coins sometimes used thin layers over base metals to balance aesthetics and intrinsic value. Metallurgical studies of these pieces reveal careful control over composition and craftsmanship, reflecting economic strategies designed to maintain trust in circulating currency while conserving precious resources, demonstrating sophistication in early monetary systems. In chemical laboratories, compounds formed with halogens exhibit vivid coloration and catalytic behavior. Reactions involving chlorides, bromides, and iodides provide insight into bonding, surface chemistry, and electronic structure. These experiments leverage the material's inertness and unique electron configuration to create stable intermediates otherwise unattainable with less noble metals. Pre-Columbian artisans in Central and South America cast small figurines, amulets, and ceremonial objects, often representing animals, deities, and mythological stories. These works reflect cultural, spiritual, and social significance, demonstrating that the value of the metal extended beyond economic wealth to narrative, ritual, and symbolic functions, surviving as a testament to craftsmanship. Nanofilms applied to silicon, glass, or polymers can manipulate light and electron flow at the nanoscale, enabling photovoltaics, sensors, and photonic devices. Even atomic thin layers dramatically alter surface properties, bridging ancient material utility with advanced technological applications. Precision deposition ensures functional and optical uniformity, critical for reliability and efficiency. Hydrothermal fluids in the Earth's crust concentrate metallic elements in veins, precipitating them when temperature and pressure change along fractures. Miners historically exploited these veins by following fault lines and fissures, uncovering lode deposits that can extend for kilometers. Understanding geologic context is vital for exploration and long-term resource management. Artisans in ancient Egypt and the Americas employed depletion techniques to enhance surface appearance, producing rich, lustrous surfaces without excessive consumption. This practice demonstrates resourcefulness, aesthetic vision, and deep metallurgical knowledge, showing how human ingenuity maximized visual impact while conserving material for ceremonial, decorative, or functional purposes. Tectonic shear zones concentrate heavy elements through heat, pressure, and chemical mobility, creating elongated veins across kilometers of rock. Exploration relies on mapping fractures, mineral associations, and structural deformation. These zones demonstrate the dynamic interplay between geophysics and chemistry in forming accessible deposits from otherwise dispersed atoms embedded deep in Earth's crust. urban recycling initiatives recover substantial amounts from obsolete electronics, turning cities into secondary sources. Shredding, separation, and chemical extraction reclaim particles from circuit boards, connectors, and other components, reducing reliance on mining. This approach demonstrates how high-tech waste becomes a sustainable resource for jewelry, industrial, and technological applications. Volcanic eruptions deposit fine particles of heavy metals in surrounding soils and sediments, which rivers later transport downstream. These dispersed grains can accumulate over time, forming localized concentrations in streambeds and valley gravels, creating accessible placer deposits. Nature's redistribution of material transforms catastrophic events into potential resources centuries later. Ancient treasuries held ingots, coins, and ceremonial items as markers of both wealth and political influence. Inventory lists reveal meticulous oversight, reflecting governance, taxation, and economic strategy. These reserves financed warfare, monumental construction, and diplomacy, reinforcing both fiscal stability and social hierarchy, while simultaneously preserving material for future ceremonial and utilitarian purposes. As our journey through gold's celestial beginnings comes to a close, allow yourself to sink even deeper into relaxation. Picture the quiet shimmer of stardust settling softly, the gentle echoes of cosmic fires fading into calm. Feel your thoughts drifting like golden particles across the vast night sky, your muscles releasing any tightness, and your breath flowing freely and effortlessly. Rest here, fully supported in this safe and serene space. If you enjoyed this relaxing moment, please consider leaving a like, subscribing, and turning on all notifications so you don't miss any of our future videos. But for now, let your body relax, release any tension, and allow your mind to drift. Good night and sleep well.